Okay, hello everyone, welcome back to another video. Today we're going to be looking at another Oxford integration question which stumped quite a few students, so I'm quite excited to share it, and thanks for all the support on my last video about a similar topic. So it gives us two equations I've labelled here as 1 and 2 for a function f of x which we don't know. Again, we don't know what this function is, we know it's continuous and that's about it. Now the first equation tells us that the integral from 0 to 1 of 3f of x dx plus the integral from 1 to 2 of 2f of x dx equals 7, and our second equation tells us that the integral from 0 to 2 of f of x dx plus the integral from 1 to 2 of f of x dx is equal to 1. Now the question asks us to find the value of the integral from 0 to 2 of f of x dx. So with that in mind, let's just focus in on equation 1 first and see what information we can extract from this. And what we're going to want to do, after of course pulling out some constants, which we can do, so we can pull out a 3 here and we can pull out a 2 over here, which gives us that 3 times the integral from 0 to 1 of f of x dx plus 2 times the integral from 1 to 2 of f of x dx is equal to 7. And given that we're integrating the exact same function, of course our multiples are slightly different, but between different bounds, let's think geometrically about what we're doing. Well, let's say there's a given shape of a function. Of course that's arbitrary because f of x, well, we don't know what shape it takes. If we integrate from 0 to 1, we capture the area in between 0 and 1. And similarly, if we integrate from 1 to 2, we capture the area in between 1 and 2 on the x-axis. Which means that if I add the integral from 0 to 1 to the integral from 1 to 2, really I'm capturing the area all the way from 0 to 1, then 1 to 2, which is the same as just going straight from 0 to 2. So that means that if I were to rewrite my expression here as the integral from 0 to 1 of f of x dx plus 2 times the integral from 0 to 1 of f of x dx. So here I've split my 3 into a 1 and a 2, and you'll see why in a minute, plus 2 times the integral from 1 to 2 of f of x dx. Well, here, the integral from 0 to 1 and the integral from 1 to 2, when added together will give us the integral from 0 to 2, and I've got two lots of them. So this is the same as just saying plus 2 times the integral from 0 to 2 of f of x dx equals 7. And of course the reason I have my 1 left over here is because I don't have enough integrals from 0 to 1 to add to all of my integrals from 1 to 2. I actually have 1 left over. So that's what we've done with equation number 1. And let's call back to equation number 2. That tells us that the integral from 0 to 2 of f of x dx plus the integral from 1 to 2 of f of x dx is equal to 1. And you may spot this instantly, but actually all that we're missing on our first equation to take our integral from 0 to 1 into an integral from 0 to 2 is that extra integral from 1 to 2 that we didn't have over here. But it seems that that integral is present in our second equation over here. So if we were to add both of our equations together, perhaps that would yield the answer that we're looking for. So let's try it. That's going to give us a new expression, which I'm going to write at the top. So we're going to add an extra integral from 0 to 2 of f of x dx, and I've already got 2 over here, so that's going to give me 3 times the integral from 0 to 2 of f of x dx, plus our integral from 0 to 1 of f of x dx that we have from our first equation, and then plus our integral from 1 to 2 of f of x dx that we have from our second equation, and this is all equal to 7 plus 1, which is 8. And now we're going to combine, as we have done before, our integral from 0 to 1 with our integral from 1 to 2, all into just one integral from 0 to 2, like so, and that means we've got 3 lots of the integrals from 0 to 2 over here and 1 integral from 0 to 2 over here. And so finally that yields that 4 times the integral from 0 to 2 of f of x dx is equal to 8. And we can do our final step, divide by 4 on each side, and we get the integral from 0 to 2 of our function must be equal to 2. Hope you've enjoyed this video. Again, it's another shorter style one, and let me know what kind of stuff you'd like to see in the future, if you're enjoying this kind of thing. And I'll leave as a challenge again for you guys to speculate about what kind of function this could be. What could it look like? And let me know your reasoning for why. Thanks for watching and see you next time. Bye.